So I would like us to look at the differentiation of y is equal to x n kx raised to power n. In our case here, you can see here the coefficient of x is 1, and in the equations that we had the coefficient as 1. So I want us now to consider a case whereby our coefficient is not 1, but it is a certain constant more than 1. So we are going therefore to have, when we want to find the dy all over the dx, it will simply be we differentiate x raised to power n, but then we multiply by the constant. So the constant, we just multiply by that constant. So the constant is there, we multiply by the derivative of this, which is n x n minus 1. So it's simply finding the gradient function of x raised to power n, then we multiply by the constant k. So that's how we find the derivative of the equation y is equal to x kx raised to power n, such that if we are finding the gradient function of y is equal to 2x squared, it simply means that dy all over the dx will therefore be equal to, we have our 2 which is our constant, so we need to differentiate this, which is now 2x 2 minus 1. So we are going to have this as 2 into bracket, we have 2x raised to power 1, and therefore we have 4x, because x raised to power 1 is the same as x. So we have our derivative as 4x. So that is the derivative or the gradient function of the equation y is equal to x 2x squared. Again, if we have another one here whereby y is equal to negative a half, then we have x raised to power 4. Again, we follow the same. Our constant here is negative 2, and therefore our dy all over dx will be, we have our constant which is negative a half, and then we find the derivative of x raised to power 4, which is 4x raised to power 4 minus 1, which is going to be negative a half, we multiply by 4x raised to power 4 minus 1, that is 3. So we end up getting by 2, 1 by 2, 2, we get negative 2x raised to power 3. So that becomes our derivative for the equation y is equal to negative a half x raised to power 4. Again, this is our A, our example B. Again, if we have the following, y is equal to 3x raised to power negative a half. Again, we follow the same to find the derivative. So we are going to have dy all over dx to be equal to 3 is the constant. Then we find the derivative of x raised to power negative a half, which will be negative a half x raised to power negative a half minus 1. So we are going to have 3 negative a half x. We have negative a half minus 1. That will be negative 1.5, which is the same as negative 3 over 2. And therefore, we are going to have, when we multiply this by this, we get negative 3 over 2x raised to power negative 3 over 2. And that will be now the derivative of the equation y is equal to 3x raised to power negative a half. So that's how we differentiate, and differentiation. We have differentiation of that. So that's how we differentiate the equation y is equal to kx raised to power n. So we have to multiply, we just find the gradient function of x raised to power the n, and then we multiply by the constant. Like in our case here, the constant is 3. Here the constant is 2, so we are multiplying by this. So we are not differentiating this constant. So we still have the 2, we have the negative a half, then we differentiate the x raised to power 4. So I would like you to do the following for this before we move on to the derivative of a polynomial. I would like you to differentiate the following, In the first one, we have y is equal to 2x raised to power 3. Then we have Roman 2, y is equal to negative 1 over 4 x raised to power 5. Then we have number 3, y is equal to 4x raised to power negative a third. And finally, number 4, y is equal to negative 1 over 5x raised to power 10. We can have raised to power 11. So I'd like you to differentiate this, or to find the derivative, or to find the gradient function.